What is up, people, and welcome to another video. In this video, we're going to be taking a look at what it takes to run RabbitMQ on top of Kubernetes. In a previous video, we've taken a look at the basics of running RabbitMQ, how to spin it up, how to create an application that pushes messages to a queue, how to create an application that reads messages from a queue, and then in a follow-up video, we've taken a look at how to set up a highly available cluster on RabbitMQ. So that involves setting up a bunch of nodes and then looking at mirroring and clustering and how to synchronize data across each node. In this video, we're going to combine all of that magic and take a look at what it takes to run all of that on top of Kubernetes. So without further ado, let's go. So the RabbitMQ clustering guide is very important to understand how RabbitMQ clustering works. So in a previous video, we've covered how the RabbitMQ nodes are identified, the requirements for clustering. We spoke about the networking and how they find each other over DNS. We also spoke about what data is and what isn't replicated on the cluster. That's very important. We're going to be looking at that today as well. And then more importantly, how clusters are formed. So there are several ways of forming a cluster. In the previous video, we've taken a look at how to set up a cluster manually. We also took a look at how to set up a cluster using a config file. In this video, we're going to be taking a look at the declarative Kubernetes discovery plugin. So we've covered config file and we've also done this manually, but today we're going to be taking a look at the Kubernetes one, which is basically a plugin that we need to go and enable on our RabbitMQ instances. So if you're new to this channel, everything I do is on GitHub. So we've got the Docker development YouTube series GitHub repo, and everything I'm going to do in this video is in the messaging folder. Then I've created a folder for RabbitMQ for this entire series. Inside this folder, we have a README guide, so you can follow along with all the steps I've done in the series. That is how to create a RabbitMQ instance manually, looking at the basics, building an application that puts messages in the queue, and also an application that reads messages from the queue. Then I also have a Kubernetes folder inside here where everything we're going to be taking a look at and all the steps are documented in this README file, which is the README file over here. This is how to run RabbitMQ on top of Kubernetes. So be sure to check out the link down below in the description box so you can follow along. Now the first thing we're going to need is a Kubernetes cluster. So the easiest way to use this is either using Docker on Windows to get a Kubernetes cluster, or you just use something like kind. So I can say kind create cluster, pass in the name, and then pass in a Docker image with a specific version of Kubernetes. Kind is great because it allows us to run Kubernetes locally using Docker containers so we can create disposable clusters. So I'm going to say kind cluster create. I'm going to call my cluster Rabbit, and I'm going to pass in Kubernetes 1.18.4. That's going to go ahead and spin up a cluster inside of a Docker container that we can use for this demo. So the next thing we're going to need to do is create a namespace on that cluster. So what I'm going to do is I'm going to say kubectl create ns, and I'm going to create a namespace called rabbits. That's going to allow us to house all our resources like our RabbitMQ cluster and all the components that make up the cluster inside a resource group. So the next thing we're going to need to do is determine the storage available in our cluster. So we do that by looking at the storage class. So if I say kubectl get storage class, we can see that we have a local provisioner here called standard. Now this depends on the cluster you're running. So if you're running in Microsoft Azure, you're probably going to use something like a managed disk. If you're running in AWS, you might need something like an Elastic Block Store, Elastic File Share. So this highly depends on the cluster that you're running. If you're new to storage classes and persistent volumes, check out my link down below to a video that I've done on persistent volumes. That'll take you through the steps of what storage classes are, how to create provisioners, and how to attach storage into Kubernetes. For this demo, I'm just going to use a local volume that's tied to the host. So I'm going to need to grab the storage class name called standard, and we're going to be using that when we spin up our stateful set for RabbitMQ to tell the stateful set what storage to use. Now the next thing we're going to be doing is creating the RBAC permissions and the service account that RabbitMQ will run under. So if we take a look at our Kubernetes folder, we have a Rabbit RBAC YAML file, and in here we're going to be describing a few things. So the first thing we do is create a service account called RabbitMQ. So our RabbitMQ instance is going to be running as the service account, and we're going to need to provide it permissions so that these instances can make a call to the Kubernetes API. The Kubernetes discovery plugin for RabbitMQ requires access to the API in order to discover other peers on the network. So in order to allow that, we're going to need to create a role. So we create a role called RabbitMQ, and we give it access to list, get, and watch endpoints. So it's able to pick up endpoints running in the namespace, so basically other RabbitMQ instances, and then it's going to be able to discover and connect with them. So then what we do is we create a role binding to hook up that service account to the role, and we do this in the Rabbit's namespace. So to do that, I'm going to change folders into the messaging RabbitMQ folder, and I'm going to go ahead and run this command. That's going to say kubectl apply. In the Rabbit's namespace, I'm going to apply the Rabbit RBAC file that we've just taken a look at. That's going to go ahead and create the service account and the role bindings. Now the next bit we're going to be taking a look at is the authentication. So part of the RabbitMQ clustering guide, there's a bit in the document that describes how nodes talk to each other. This is done through the Erlang cookie. So basically when running the RabbitMQ CLI, you have to have your CLI configured with the same cookie as the node you're trying to talk to. For clustering, it's really important that all the nodes in the cluster have the same Erlang cookie. So to set up this authentication, what I've done is created a secret with that cookie value in it. So you're going to head over down to the Kubernetes folder. There's a secret.yaml, and here we can see we're going to set the cookie into the environment variable that RabbitMQ looks at. So RabbitMQ looks at an environment variable called RabbitMQ Erlang cookie. So what I've done is I've taken a cookie value and I've made a base64 out of it. So I said echo -n, pass the cookie value and pipe it to base64. That is the standard of Kubernetes. When you create a secret, you need to provide the base64 value, and I'm going to put that value in here. So now we're going to go ahead and deploy that to our Kubernetes cluster, which is going to create a secret. So to do that, I have all the commands listed here. So I'm going to go ahead and grab that command, and I'm going to say kubectl apply. In the Rabbit's namespace, I'm going to apply that secret file. That's going to go ahead and create a secret for the authentication piece. Now the next bit we need to talk about is the discovery mechanisms. This video we're going to be taking a look at the Kubernetes plugin. So if we take a look at the config map, this is the configuration that we're going to be using. So firstly, what we need to do is we need to provide the enable plugins file. This file basically runs on RabbitMQ instance, and it tells RabbitMQ what plugins to enable. So if we take a look at this file, we see that I want the federation plugin enabled. This plugin is going to allow us to federate and synchronize queues and messages across different instances. We have the RabbitMQ management plugin that's going to give us the user interface and the dashboard, and then we're also going to enable the plugin for peer discovery for Kubernetes. This plugin is essential for the discovery mechanisms to work. The next bit we're going to do for this configuration to work is we have to define the backend for the discovery here, and we tell RabbitMQ to use this plugin, which is the Kubernetes discovery plugin. The other bit of important information is we need to specify where the API server is. This is because RabbitMQ is going to try to make a call to the Kubernetes API to discover other RabbitMQ instances and hook up a cluster. So we basically just say kubernetes.default.service.cluster.local. That is where the API server is. Now the RBAC permissions are crucial because the RBAC permissions will allow this instance to connect to the API server. The other bit of information that's important is to set up the address type to hostname. There's multiple ways for RabbitMQ to connect to each other. There's IP address and hostname. Hostname is very important. We're going to be using a headless service in Kubernetes to expose each of the pods on their own DNS. So that's very easy to apply. All I'm going to go ahead and do is say kubectl apply. In the Rabbit's namespace, I'm going to apply that config map. That's going to go ahead and create the config map. So now we're ready to deploy our cluster. So next up, we're going to be taking a look at how to deploy the RabbitMQ instances. Now for this video, I'm going to be using a stateful set. A stateful set is very important when it comes to stateful workloads. Like you want to persist the queue and the messages, as well as a couple of other features. Stateful sets allow us to give us a stable network identity. So if you use a deployment and a pod, the pod names will be random, meaning you'll get random host names. So the RabbitMQ instances will find it very difficult to peer with each other. The other benefits of using a stateful set is we can provide every pod with their own persistent volume, and we can also bring a storage class that can bring any kind of storage that you wish to bring. If you want more information on persistent volumes and stateful sets, I have a stateful set video that I want you guys to have a look at. That'll show you all the benefits and features of why stateful sets are important in Kubernetes. So in this example, I'm defining a stateful set called RabbitMQ, and I'm going to create 4 replicas. We're also able to scale this up and down automatically. When we scale it up, the Kubernetes will provision more pods, create more persistent volumes mounted into the pod, and also the Kubernetes plugin will automatically pick up those new peers of the RabbitMQ instance that comes up. So what we're going to do next is, this is the critical part, is we have to specify an account name that we want this pods to be running as, so that the pod can make a call to the Kubernetes API and discover other peers. Now there's a bit of an important bit here. So when RabbitMQ uses configs like the plugin config and its configuration file, it needs to be writable. Now usually when you create a config map and you mount it to a pod, it becomes a read-only volume. To work around that, I've created an initialization container, and I've just created empty directories as volumes. So what we're going to be doing, if we scroll down temporarily and we have a look at this, what I'm doing here as a volume is I create a config volume. This is for all our config, and I create another volume for the plugin configs. Then over here, I'm mounting the config map that we've just created into the read-only volume, and the job of the init container is to run a busybox container before the RabbitMQ instance starts. And what that's going to do is that's just going to copy out from the config map volume. It's going to copy out those files into the empty directory. So it's going to copy it to the plugin config folder and to the plugin file folder, because these two volumes here are not read-only. So RabbitMQ instance, when it starts, it can look at this folder as well as the config folder to pick it up, and it will be able to write to those files. So that's the job of the init container. Then if we take a look at the RabbitMQ instance, it's very straightforward. We're running RabbitMQ 3.8, the management one, because I want the management plugin to be baked into the image. And then I'm exposing two ports. The one is the discovery port for the clustering to work, and the other one is the port for clients, like when we create some code, an example app to connect to the queue, to produce messages or read messages, we want to be able to expose this port. The next bit of information we need is we need an environment variable for the pod name and the namespace name. So what we do is we create an environment variable called Rabbit pod name, and we get that from the Kubernetes downwards API. Then we also create one Rabbit pod namespace, and we grab the namespace from the Kubernetes downwards API as well. We need these two environment variables because we need to specify what the RabbitMQ node name is. So the RabbitMQ instance as a pod will know what its node name is to make it available for discovery. So basically we're just going to do some string manipulation here, and we're going to put the node identifier, which is Rabbit, and then we're going to put the pod name, and then the name of the Kubernetes service, which I'll show you soon, then the name of the namespace, and then service.cluster.local. This is going to form a fully qualified domain name that services can find each other on the network. We then also tell RabbitMQ that we want to use long names because we're using a fully qualified domain name and not a short host name. We have to specify this value as true. Then we also tell RabbitMQ to look at this path to find the config file. That is the path where the init container is going to copy in our config map file. Then we also specify the Erlang cookie, which is the secret, so it will use this cookie to authenticate with one another. And then the final value here is the Kubernetes plugin's hostname suffix. So we tell the plugin that this is what the suffix looks like for the hostname. Then the final bit is we just mounting a bunch of volumes, but the critical one is we mounting a volume called data. If we take a look down at the volume claim templates, this is part of the beauty of a stateful set. It's able to tell Kubernetes to provision persistent volumes for each pod using the storage class name that we looked at earlier. So you need to say kubectl get storage class and then provide that name that you want to use here. So I'm going to create a local storage, and I'm just going to pass in that I want 50 megabytes of storage for this demo. The last bit is really important. It's the headless service. Now we need to create a service to expose each of the pods of the stateful set. We don't want load balancing. So to turn off load balancing, we create cluster IP none. This will specify a headless service, which basically means that every pod in the stateful set gets its own DNS name, which is that fully qualified domain name that I showed you earlier. We then also expose a bunch of important ports, the discovery port, as well as the port for applications to connect to put messages into the queue and to read messages from the queue. So it's very simple to deploy that part. I'm just going to say kubectl apply in the Rabbit's namespace, and I'm going to apply the stateful set. That's going to go ahead and provision a stateful set, which is going to create a pod one by one, and then also create storage and attach it one by one, and then also provide a stable network endpoint, as well as using the Kubernetes plugin to start connecting to each other and form a cluster. If I do kubectl get pods in the Rabbit's namespace, you can see it's creating pods one by one. That's the beauty of stateful sets. It doesn't create it all at once, it creates it one by one. And if I do kubectl get pvc, we can see that it's also creating storage one by one as well. Then what I can do to test this out, I can say kubectl get pods. I can grab any one of the pods and say kubectl port forward to that pod, and I can go ahead and port forward to the management port interface. And then we can go ahead and log into this on port 8080. And we can now see that we have a RabbitMQ dashboard, and we also have 4 instances of our RabbitMQ cluster running. So now that we have a cluster up and running, let's try to interact with it and write an example application that's able to connect to this instance. So what I'm going to do is I'm going to open up a new terminal, and I'm going to just quickly change directory into the messaging RabbitMQ applications publisher folder. You can see that I have two applications here, one publisher that puts messages into the queue and a consumer that reads messages from the queue. So to test the resiliency, what I'm going to do is I'm going to change directory to this folder, and I can go ahead and build my application. So I can say docker build and dot, and then I can just pass in a tag. That'll go ahead and build my application, and then I can say docker push to push that up to Docker Hub for Kubernetes to be able to deploy. So if you want to follow along, you can check the README file. I have a step on how to build this application, and then to deploy it, you can see I have a deployment YAML file in here as well. So we can just say kubectl apply in the Rabbit's namespace, and we can apply this deployment.yaml. That'll go ahead and create an example application as well as a secret in order for it to connect to the queue. So if we take a look at that very briefly, we have a deployment, we have a secret in here. This is a Rabbit username and password to connect to the queue. We also have a basic deployment. We're going to deploy our image here, and over here we specify the connection details. So we give it a fully qualified domain name of the instance. So this application is going to connect to the first instance of the cluster and put a message in over this port. We're also going to expose the application via a load balancer, so we can just very easily go over localhost if we wanted to. And then I can go ahead and I can push messages. So I can push a message to the publish endpoint of my publish application. I can push a message called hello. So I can go ahead and run this a couple of times. And then if we head back to our dashboard, we can see there's been activity now. So if I go ahead and refresh that, we can see we have 5 messages in the queue, and the message should be on this instance, on the first instance of the application. Now, how do we set up mirroring and a policy that distributes these messages across the cluster? By default, if this pod dies, our message will be lost. So we need to make sure we set up some sort of cluster mirroring in order to mirror the data across multiple instances to make it highly available. Now, I highly recommend you read the documentation on classic mirror queues, and basically it's an HA guide on RabbitMQ that will take you through exactly how all the mirroring and replication works. This guide will just help you move into the right direction of getting a cluster up and running, and then it's up to you to make sure that the cluster caters for your needs. So mirroring is configured using what's called policy. So what we need to do is we need to create a policy on our nodes to tell it that we want to synchronize 2 different instances. I also have a link to synchronized and unsynchronized mirrors. So basically what we want to do is we want to go into the first pod and then enable a policy. So what I'm going to do is I'm going to say kubectl get pods, take any one of the pod names, and then run the kubectl exec command to go inside of that pod. Once inside, we can use the RabbitMQ CLI to set a policy called HA federation. And basically what we'll do is we'll specify a regex statement to match any queue that we create. So I'm saying .star. That'll match any queue that any application creates, and it'll apply this federation policy to it. Now the federation policy has a bunch of different settings. Now in this mode, I'm just showing you how to do HA sync mode automatic and also provide HA modes of nodes. So I'm giving it a list of nodes I'd like to synchronize to. So here I'm saying I want to synchronize to Rabbit 0, Rabbit 1, as well as Rabbit 2. And I'm applying a priority of 1, and I'm applying it to queues. Now there's a bunch of settings that allow these different HA modes. One of them is called exactly, which is exactly a specific count of nodes that you want to synchronize to. The other one is all, meaning it will mirror to all the nodes in the cluster. This might be a feasible option when you're looking at Kubernetes, where you can run X number of nodes and you want to mirror to each one of them. It does, however, warn you that there is additional strain on the cluster nodes, which includes network IO, disk IO, and disk usage if you replicate to all nodes. So usually they recommend to only replicate to a quorum. So if you're running like 5 nodes in the cluster, you may only want to mirror to at least 3 of them. Now how mirroring works is when the master dies, it will promote a new master to the mirror cluster. The new master will basically be the last node that has joined the cluster. Or you can just provide a list of node names. So the flexibility is there. So what I'm going to do is I'm going to grab this command, I'm going to paste it in the terminal and set up our policy. So now that our policy is set up, I can go onto any of the nodes again, and I can go into queues, and I can see our queue here has now a HA federation feature enabled. If I click into that queue, we can see that we have node 0 being the master and node 1 1 and 2 is a mirror. To test out the mirroring and HA capability, I can say get pods, and I can go ahead and destroy that master pod. So I'm going to say kubectl delete pod, and I'm going to delete that pod that's currently the master. So what RabbitMQ will do internally is it'll promote the last connected one to a new master, and the other ones will become mirrors. If node 0 joins the cluster again, it'll just become a mirror. So if we do kubectl get pods, we can see Kubernetes has gone and recreated our first instance that died. We can go back into the dashboard and we can see that we had no data loss. So node 0 has come back to the cluster. If we go to queues and we click on our publisher queue, we can see that node 0 has come back and is now joined as a mirror, as well as node 1 has now been promoted to master. So this showcased to you the mirroring capabilities and the federation of running a highly available Rabbit cluster. Now do remember that it's very important to check out the RabbitMQ clustering guide that I've linked down below. That'll help you understand exactly how RabbitMQ instances behaves when a cluster is formed and how they behave when failure is encountered. It's also very important to configure your queues and your cluster accordingly to your requirements. So hopefully this video helped you guys get started with the basics of RabbitMQ clustering, as well as the basics of running a RabbitMQ instances in a cluster on Kubernetes. So let me know down in the comments below what sort of issues you're facing with RabbitMQ and what sort of videos you'd like me to cover in the future. And as always, like and subscribe, and until next time, peace.